we will be solving some of the problems based on the previous understanding. Right? Okay. So in case of simple harmonic motion, so the analysis what we have done is the fundamental rule and condition for the simple harmonic motion should be the acceleration d square x by dt square should be equal to minus of omega square times of x. So this is equation number 1. And the velocity relation is v square is equal to omega times square times of a square minus x square. So this is the velocity relation. And displacement relation is a cos omega t is the displacement relation in case of simple harmonic motion. Suppose if there is an initial phase, then this is extended to a cos omega t plus phi. So this is the with initial phase. Got it? So these are the fundamental relations actually that are there as part of this simple harmonic motion. Now based on this understanding, now actually we will solve some of the problems. You note down one. Show that if the displacement of a particle, if the displacement of a particle in a straight line is expressed by the equation, in a straight line is expressed by the equation x is equal to a cos nt plus b sin nt. It describes a simple harmonic motion. It describes a simple harmonic motion. Whose amplitude is square root of a square plus b square. Square root of a square plus b square, and period is 2 pi by n. Can you solve this? So we need to prove that this equation x is equal to a cos nt plus b sin nt, which gives the relation between the displacement and the time. And for that relation actually we have to prove that this displacement describes the simple harmonic motion, which essentially means that this solution satisfies this differential equation. That's all. Got it? Yeah. Can you try to solve that? And based on that, I will try to find out the amplitude as well and the time period. Okay. So let me solve it. See this, x is equal to a cos nt plus b sin nt. Now if you take the derivative of it, dx by dt is equal to a into derivative of cos is minus sin, b into derivative of sin is cos. Now if you take the derivative again, d square x by dt square is equal to minus a into n square into derivative of sin is cos nt plus, and here b into n into, so again n square, derivative of cos is minus sin nt. Now if you notice, if you take n square out, minus of n square out, a cos nt plus b sin nt, which essentially states that this is equivalent to the displacement. Now from this relation, you can make out d square x by dt square is equal to minus n square times of x. So this is, if you notice, d square x by dt square is proportional to x and is in opposite direction. So hence it describes a simple harmonic motion. So this equation represents a simple harmonic motion. Now actually we have to find out the amplitude, which is equal to square root of a square plus b square. So this way actually there are two different ways we can approach this problem. Now this actually you can further simplify. This x is equal to, so a cos nt plus b sin nt. So what I will do is I will divide with the square root of a square plus b square, and I will multiply with square root of a square plus b square, so that actually the equation won't change. So top and bottom actually I have multiplied with square root of a square plus b square. Now here this one you can call as, so this is cos, right? So this is actually I will take as sine, or actually I will call this as cos. So this is a and this is b, this is square root of a square plus b square. Now this angle is phi, if I say, then actually a by square root of a square plus b square I can call as cos phi, and this I can call as sin phi. So this can be called as a square plus b square under root multiplied by cos nt cos phi plus sin nt sin phi. So square root of a square plus b square getting multiplied by cos nt cos phi plus sin nt sin phi. Once you note down this, we will erase and then actually complete this problem. Now from this relation, so we have got x is equal to square root of a square plus b square, and then cos nt cos phi plus sin nt sin phi. Now this can be further expressed as square root of a square plus b square cos of nt minus phi. Now if you notice, the displacement relation in this particular format represents a simple harmonic motion, whose amplitude is this one. So amplitude square root of a square plus b square, and then here actually our standard equation is x is equal to a cos omega t plus or minus phi. This is the equation of the simple harmonic motion, wherein this omega is the angular frequency and this phi is the initial phase angle. And this A is the amplitude. So if you correlate it, so omega is equal to n, and we know that omega is equal to 2 pi f is equal to n, or f is equal to n by 2 pi, and this is also called as 1 by t, or t equal to 2 pi by n, so whatever it may be. So all are one and the same. This is one way you can approach the problem. The other way you can approach the same problem is here with the assumption that this is known to be the simple harmonic motion. With that understanding actually we proceeded. The standard method of analyzing the same problem is the amplitude is the place where the velocity is equal to 0. So there the displacement whatever it describes with which velocity equal to 0 is called the amplitude. That means in the simple harmonic motion, this is the center of force and this is the extreme position where velocity momentarily comes to 0. And with that condition actually you will be able to find out again So we have got the displacement relation. X is equal to A cos nt plus B sin nt. And then the derivative of this is dx by dt, which is nothing but the velocity of the particle, and minus a n into derivative of cos is sin nt plus bn into cos nt. And this value equal to 0, where it describes the maximum amplitude, or the amplitude itself is the maximum value always. So with that condition, so minus an sin nt plus bn cos nt equal to 0. From here, so you can say sin nt by cos nt is equal to b by a. So this is tan nt. So tan nt equal to b by a. Now, if tan nt equal to b by a, so this you can call this as, so this is phi b and this is a, and this is square root of a square plus b square. Now actually, so we have got the value of tan nt, and from here actually sin nt and cos nt we can find out. Sin nt equal to b by square root of a square plus b square, and cos nt equal to a by square root of a square plus b square. And these values of sin nt and cos nt you can substitute in the displacement relation to get the place where the velocity equal to 0, which we call as the amplitude. So if you replace these values here, you are going to get x is equal to square root of a square plus b square. That's all. And this is how actually can solve any of the information whatever is needed in case of simple harmonic motion. Got it? Any questions on this? The speed v of a particle, the speed v of a particle moving along the axis of x is given by the relation v square equal to n square into 8bx minus x square minus 12b square. Show that the motion is simple harmonic motion. Show that the motion is simple harmonic. With its center at x is equal to 4b, with its center we mean here the center of force at x is equal to 4b, and amplitude equal to 2b. Can you try to solve this problem? So he has given the velocity and displacement relation. From there actually we have to prove that the second derivative of x, which is nothing but the derivative of v, is directly proportional to x and is in the opposite direction. Got it? So try to prove this relation. Anyone got it? Okay. So let me solve it. See this. Here the velocity relation is v square is equal to n square times of 8bx minus x square minus 12b square. Now if you take the derivative on either sides, so this is 2v dv by dt n square times of 8b into dx by dt minus 2x into dx by dt. Now here n square, you take 2 out, then 4b minus x into dx by dt, and here this v I will write as dx by dt because actually v is equal to dx by dt. And this dv by dt, I will keep it as it is, and this dx by dt will cancel out, and this 2 will cancel out, and dv by dt I can write as d square x by dt square is equal to 4b minus x. Now here actually what I can do is I can take this minus out so that actually I can get the x value first. So d square x by dt square equal to minus x minus 4b. Now if you notice, if I call this as capital X is equal to x minus 4b, which is the shifted coordinate axis, and d square x by dt square is equal to d square x by dt square. So this is capital X and this is small x. So this is as if like d square capital X by dt square is proportional to capital X and is in the opposite direction. So hence it represents a simple harmonic motion. Now here actually the simple harmonic motion applies after shifting the coordinate axis to capital X, where capital X equal to 0 but small x is equal to 4b. So if you are shifting the coordinate axis from here to here, where this is x equal to 0 to x equal to 4b, and x minus 4b capital X is nothing but x minus 4b, and this is equal to 0 with respect to this coordinate system. So you are shifting the coordinate system from here to here, which essentially means that wherever x is there, you will be replacing with x minus 4b. That is the shifting of coordinate axis, where capital X and small x are related as capital X is equal to x minus 4b. Now with that understanding, so by taking the reference point or the center of force at the capital X equal to 0, it will be in the simple harmonic motion with the relation of d square x by dt square is proportional to minus of x. So this is again a simple harmonic motion with the center at x is equal to 4b or capital X equal to 0. So with respect to, so known value is small x, hence small x is equal to 4b is the center of force for the simple harmonic motion given by this relation. Now here, if you want to find out the amplitude is always the place where the velocity becomes 0 momentarily. Now if the velocity becomes 0, then actually if you put v is equal to 0 in this relation, you are going to get the quadratic equation. So where you can solve for the x value, which will give the position where the velocity becomes 0. Now in a simple harmonic motion, if this is the center of force, there are two different places actually where the velocity momentarily becomes 0, and this is 4b, and then obviously there will be an additional value 4b plus 2b will be 6b here and 2b here. So this is how you are going to get it. Now actually we will solve for the amplitude in two different ways. We can do that by taking velocity equal to 0, or actually you will be finding out the distance between these 2 points, and exactly half of that value will be the center of force. Got it? Okay. So first you note down this, we are going to solve for the place where the velocity becomes 0. So the value of x at which the velocity becomes 0, this you can make as 0 is equal to n square 8bx minus x square minus 12b square, or this can be called as x square minus 8bx plus 12b square. Equal to 0. Now for this actually you can solve for x. X is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this value is 8b plus or minus, here actually 4 12s are 48. So 64b square minus 48b square. So this is 16, then it will come as 4b by 2. So this is 4b plus or minus 2b. So 4b plus or minus 2b are the two values. So here actually one value is x is equal to 4b plus 2b is 6b and another value is 2b. So if you notice, the center of force actually is coming at x is equal to 4b. Now from there actually one position is 6b and this is 6b position and another position is 2b. So the amplitude usually comes as the midpoint. So if you count this value 2b plus 6b is 8b, the midpoint will be the half of the sum of these two, which is the average value between these t. 6b plus 2b by 2 is equal to 4b, which is the center of force. Now the distance between these 2 points is nothing but the amplitude, because from the center of force till the place where the velocity becomes 0 is called the amplitude. Here this distance is nothing but 6b minus 4b is equal to 2b. This is the amplitude. This side also you can count 4b minus 2b is the amplitude. So anyway actually this will come as 2b. So this is the amplitude of the simple harmonic motion. Got it? So this way, right? So usually actually so difference of the roots of this equation where the velocity becomes 0 is nothing but the amplitude. Usually that is the case. Note it down. In a simple harmonic motion, of period 2 pi by w, of period 2 pi by omega, if the initial displacement be x naught and the initial velocity be u naught, be x naught and the initial velocity be u naught, prove that. So he asked for different values. One is amplitude is equal to square root of x naught square plus u naught by u naught square by omega square. This is the amplitude. And position at time t. Square root of x naught square plus u naught square by omega square multiplied by cos of omega t minus tan inverse of u naught by omega x naught. And time to the position of rest. T is equal to 1 by omega tan inverse of u naught by omega x naught. So can you try to find out these values? So if you notice carefully, he asked for very simple information, though it is looking as complicated. He asked for one is the amplitude and another is the position at time t. So at any random time, if I ask where is the position of the particle, so you have to find out the position of the particle from the same differential equation. And time to the position of rest is nothing but time taken to reach the for the first time when it reaches the velocity 0 position, which is the extreme position where it is the amplitude. And that is where actually time took is 1 by omega times of tan inverse of u naught by omega x naught. So these are the values actually he asked us to find out. Only difference between the previous problems versus now is, in the previous problems actually, the extreme position we have taken as the initial position where t equal to 0. The particle is started from there. Suppose this is the extreme position at t equal to 0 and x is at t equal to 0, x equal to a. So this is the initial value and where v is also 0. Now actually what he asked was at one place actually he mentioned some random position where at x is equal to x naught, this is where actually t is equal to t naught, and there is an associated velocity in the opposite direction. That velocity will be v is equal to u naught. So as I explained earlier in the previous class, right? So I told you like actually the increasing direction of x is the opposite direction of the velocity. So that is the usual case of a simple harmonic motion, because so at t equal to 0 we started the particle at this location, and where the particle started moving in the opposite direction, which is the decreasing direction of x. That means v direction and x direction are always opposite to each other. Even if you take it here, when the particle is moving in the increasing direction, the velocity initial direction this way we have treated as positive. Hence the particle is moving in the increasing direction of the x, but is treated as the opposite direction of the velocity. So the x direction and v directions are always opposite in nature in case of simple harmonic motion, because that is what is the initial convention what we followed in deriving the equations. Now here actually this is the place, rather than giving the information at this location of the initial condition, he has given at some location where x is equal to x naught and v is equal to u naught at t is equal to 0. So from there actually the initial conditions are going to be changed, but the analysis won't be changed. Got it? So based on that understanding, you try to prove this relation. Okay, so let me solve it. See this. So the differential equation of a simple harmonic motion is d square x by dt square is equal to minus omega square times of x is the differential equation of the simple harmonic motion with the time period of 2 pi by omega, where omega is the angular frequency. Hence this comes as omega square, which we proved in the previous session. Now here d square x by dt square I multiply on either sides with 2 times of dx by dt. Now actually I can do the integration on either side with respect to dt. Now this dt will cancel out, and here this is 2v into dv by dt. Call this as 2 times of dx by dt and d by dt of dx by dt. Then this is equal to minus of omega square into 2 times x into dx. So this side actually when you integrate it, so this is 2v times of d by dv integral is equal to minus 2 omega square into x square by 2 plus c. So this is v square by 2, and this is equal to minus 2 omega square x square by 2 plus c. This 2 will cancel out, 2 will cancel out, and we have got the fundamental relation v square is equal to c minus omega square x square. So this is the fundamental relation between the velocity and the displacement. Now from this relation, the initial conditions, if you substitute it, so at t equal to 0, that is x equal to x naught, v is equal to u naught. So this is the initial relation. Now at x is equal to x naught and v is equal to u naught, so this is going to be u naught square is equal to c minus omega x naught square. So c is equal to u naught square plus omega x naught square. So this is the value of c, where you can substitute in this equation v square is equal to u naught square plus omega into x naught square plus omega square x square minus of omega square x square. So this is the relation.
Now if you notice, this is as if like a square minus okay. So if you take omega outside in this relation, omega square x naught plus u naught by omega whole square minus omega square x square. Now take out omega square out. Then actually x naught plus u naught by omega whole square minus x square. So if you compare this relation with the previous relation of v square is equal to omega square into a square minus x square, where instead of a square this is of the form x naught plus u naught by omega whole square. So here actually this entire thing forms as the a square value, where a is the amplitude which is known to be. Got it? First you note down this, we are going to further continue this. Now from this relation, so we have got the amplitude value as square root of x naught square plus u naught by omega whole square. A is equal to x naught square plus u naught by omega whole square. So this is the amplitude. Now from this relation, so v square equal to a square minus x square, where this a value is this entity. Now actually this can be treated as v is equal to a square minus x square under root into omega, and this is what actually we have treated as the negative value, as I explained earlier. Now here actually this dx by dt is equal to minus of omega into square root of a square minus x square, and then dx by minus of square root of a square minus x square is equal to omega dt. Now if you integrate on either sides, this is going to be minus, so let x is equal to a cos theta. Then if it is dx is equal to derivative of cos is minus a sin theta d theta. So if you replace it here, integral a sin theta d theta divided by a sin theta. Now these two will cancel out. Finally it left with theta, omega t plus some random constant phi. So this is equal to theta. So theta is equal to cos inverse of x by a, and this is equal to omega t plus phi, where phi is the initial phase angle or arbitrary constant of integration for us. Now here, so x you can call as a cos omega t plus phi. So this is the displacement versus time relation. Now here actually what he asked was, he asked us to find out the value of time position at any time t. So from here actually, so this is x equal to, sorry, this is t. So x equal to a, meaning this one, square root of x naught square plus u naught by omega whole square under root cos of omega t plus phi. Now actually this phi relation actually we can bring it from the initial conditions, right? Now, first you note down this, we are going to bring that. So from this relation we have got x is equal to, I'll keep as it is a so that I can substitute at the end, a cos omega t plus phi. Now the initial conditions are at t equal to 0, x equal to x naught and v is equal to u naught. Now if you replace it here, x naught equal to a cos omega into 0 plus phi, or x naught by a is equal to cos phi. So x naught by a is cos phi, where a is equal to x naught by x naught square plus u naught square by omega square under root. So this is cos phi value. This you can further simplify as omega x naught whole square plus u naught square. In the numerator actually omega x naught equal to cos phi, or cos phi equal to omega x naught divided by u naught square plus omega x naught whole square under root. So this is as if like in a triangle for an angle of phi, so omega x naught is this one and u naught is this one, and this is square root of u naught square plus omega x naught square. So from this relation you can get the value of cos phi as this value. So or sin phi as u naught by square root of u naught square plus omega x naught square, or tan phi as u naught by omega x naught, or in other words phi can be treated as tan inverse of u naught by omega x naught. So this is the initial value. Now actually you can substitute there x is equal to square root of u naught x naught square plus u naught square by omega square cos omega t plus tan inverse of u naught by omega x naught. Got it? So this is how you can get the relation. I think this minus sign actually in the integration actually I made a mistake. So this you can treat as minus. Got it? So this is how actually you can find the value of the position or the displacement at any instant of time. Got it? So from there actually time for the rest. That means actually initially when the particle is actually somewhere it is moving with certain velocity. Now actually it has to reach the extreme position and then reach the velocity 0 there and then come back to the normal position. So in this way, first time actually when it reaches the first time 0 position or the 0 velocity position, that time actually is nothing but the time to take for the rest. So that means the velocity becomes 0. So there actually what would be the time? So that's what is the problem statement. First you note down this, we are going to solve that as well. Now from the same relation what we have got, x equal to x naught square plus u naught by omega whole square under root is equal to cos of omega t minus tan inverse of u naught by omega x naught. Now here actually at the position where the velocity becomes 0, x will be the amplitude obviously. X is equal to x naught square plus u naught by omega whole square under root. So this is the place actually where the amplitude happens, the velocity becomes 0. Now if you replace the same value here, x naught square plus u naught by omega whole square under root is equal to x naught square plus u naught by omega whole square under root into cos of omega t minus tan inverse of u naught by omega x naught. Now these two will cancel out and cos inverse of 1 is equal to omega t minus tan inverse of u naught by omega x naught. Now cos inverse of 1 is 0. So from here actually omega t minus tan inverse of u naught by omega x naught So RT equal to 1 by omega tan inverse of u naught by omega x naught. So this is the time to take for rest. Got it? Understood? Understood, or do you have any questions on this? Okay, yeah. So that's great. So these are the kind of problems you can expect in case of simple harmonic motion. So nothing complex in this. This is pretty straightforward and simple, and there is only one differential equation, that is d square x by dt square is equal to minus kx. So that is the differential equation actually where 100% information about the simple harmonic motion is there. So whatever may be the problem, whether you know the procedure or don't know, you straight away start with the second order differential equation, and then from there you can bring out everything with the fundamental definition of dx by dt is equal to velocity and x is the displacement. So with those relations actually you will be able to find out the complete information or the complete kinematical behavior of the simple harmonic motion, which is a rectilinear motion, which is a sub part of the rectilinear motion. Got it? Any questions on this? Okay. So with this we will conclude this one. In the next class actually I am going to start with the planar motion along with the projectiles. So in planar motion actually we have the projectiles and the circular motion. So only these two are the types of motion we can think of in case of planar motion as far as the UPSC civil services is concerned, and those are anyway very simpler aspects which you can easily discuss. Got it? Yeah. So that's all for today. Thank you. Good night.